All right. So this lecture is going to be talking about research methods in psychology, which corresponds to your reading in chapter 1. So what is science? You can pause this video and take a minute to yourself. I want you to kind of think about how you would define science. Now, maybe some of you have taken other psychology courses or scientific courses, and you might know how you would mainly define science, but I want you to kind of take a moment, write down a definition of what you think is meant by the term, and maybe what are some of its core characteristics. What would make something be considered quote unquote science? Okay, so you can pause this video and take a moment to write those down. So I'm not sure what you all wrote down. You might have a variety of different things, but there was really no universal definition of the term science. It really represents a systematic approach to understanding behavior or other phenomena, right? So in the realm or field of psychology, we use science to investigate human behavior, okay? So that's what we're looking at. That's what we're using our science for. But even though there's no universal term for or universal definition of the term science, there are some core characteristics of it. So, science allows us to provide an accurate description of observed events. So, again, in the realm of psychology, we're looking at human behavior. So, science allows us to predict with various degrees of accuracy how an organism or how a human or an animal will behave given certain conditions or in certain environments that they're placed in. And when we understand why these events occur, it provides us a certain level of control. Now, the word control, when you think about it, it's not necessarily a bad word, right? So, the way in which we use terms in a scientific sense or in our scientific community sometimes differs from how we use them in everyday life. So, when you hear the word control in everyday life, it might have sort of a negative connotation. However, when we're talking about it in terms of science or in terms of research, it's not a bad thing. Okay, it's ensuring that our observations and our data that we find from those observations are accurate. So, for example, if you decide that you want to look at increasing the amount of exercise you do for a research question, essentially, and let's say you do a baseline, which basically means you take data on how much you exercise before you implement any type of treatment or change. Okay, so you take baseline data, you see how much you're exercising now, and then you implement some sort of treatment, essentially, or a protocol that you might put in place. So, for example, you might start reinforcing your behavior for every time you exercise. Let's say every time you exercise, you are able to watch 2 hours of your favorite show. So let's say you have a favorite show, you really love it, but you're only allowed to watch it if you exercise, right? So you've given yourself a special little treat, a special reinforcement for exercising every day. And before you know it, of course, you're probably exercising much more than you used to, right? If now you have something good or something positive that you're trying to earn, you'll probably see that behavior increase. So what happened? Well, scientifically, from a research standpoint, we would say that you've achieved some degree of control over this behavior. It's a good thing, right? So you've basically brought this behavior under control of certain environments or of certain outcomes, and now you see that behavior increase. So don't think of control as a bad or negative thing, even though that might be something that we think of in our everyday normal language. But within the scientific or research community, it's considered a good thing. Another core characteristic of science is known as determinism. So, this is a philosophical position that we have that basically states that events don't just occur at random. They're related to other events in some way. So, someone doesn't just randomly engage in a behavior, but we have to look at the environment they're in, other variables that are influencing them, other people that are around, certain events that have taken place, and so on. Those behaviors don't just happen randomly out of the blue. And we attempt to discover the causes of the behavior or whatever phenomenon we're investigating. So if we believe that it's not random, we believe that it's determined by other things in the environment, we of course have to use something to help us determine why that is or why the behavior occurred. And we use the scientific method. Okay, so we'll talk about that later on in this lecture. We'll go into the scientific method in detail, but that's what we use essentially to discover what does cause behavior. Now, the opposite of determinism is called accidentalism. So this basically says that events occur by accident or without cause. But we adhere typically in the scientific community to determinism, which basically says that these events are determined. They're related to other events in some way. They're not random. Another core characteristic of science is what is known as empirical evidence. So this states that we gather information about natural phenomena using experimentation and observation. We're not using hearsay or intuition. It's not a feeling about something. I feel like this should be the result. I feel like this is why this happened. No, that's not what we use. We use empirical evidence. We gather data by using observation and experimentation. Another core characteristic of science is replication. So experiments and procedures really need to be replicated to ensure that they're actually valid and reliable. You know, if only one researcher can get their results and no other researcher and no other lab and no other experimenter can get the same results, we don't have replication. Okay, we're not sure if those findings are actually accurate because only one person can get them. So replication is really a core value that is held in science and in any type of research or experimentation that takes place, because this validates your findings. So you might find one thing, but then if another experimenter finds the same thing and another finds the same results and another and so on, it's validating how reliable your data or your findings are. Okay, this is why we write method sections in our research papers. So in a method section, if you've ever read a research paper, the method section is often very dry. It is the rules or the description, the explanation of all the steps that were taken by the researcher to conduct the experiment. And the reason we write the method section is so that other researchers can read our work, see what we did step by step, exactly how we did it, how we observed the behavior, what environment the participants were placed in, whatever resources or items we had that we presented to the participant. We lay all of this out in detail so that other researchers can read it and conduct it themselves to try and replicate the findings. Okay, so a method provides basically details so that other people can replicate your procedure. Now, of course, we have some research ethics that have been established over the years. Of course, many decades ago, when we didn't have an ethics or ethical guidelines that we call them now, there were a lot of kind of iffy, kind of sketchy research experimentations that took place that probably many of you are familiar with, even if you've never taken a psychology course. You may have heard of things like the jail cell experiment, where basically they placed individuals in a prison and they made half of them the guards and they made half of them the prisoners, and they were like, let's see what happens. Completely unethical. That is not something we would do anymore. And it's because we have our research ethics and ethical guidelines that have been established. And these really have been done to ensure the safety and well-being of our participants. So that's our number one goal with ethical guidelines now when we're doing research. We always want to make sure that the well-being of the participant is always looked after. Whenever you develop a research protocol or you propose to do any kind of experiment or research, especially at a university, you have to go through a whole review board that basically looks at all of the things you're putting your participant through, with the main question being, will any harm come to the participants? And if so, what is the result of that harm? So, the main point of ethical guidelines or research ethics that we have today is to ensure that our participants are safe and to ensure that their well being is upheld against everything else. Okay. And like I said, the experiments are approved by the IRB before your research can be conducted. So the review board can actually say, hey, we think that, there is this risk that the participants are being put under, and we don't think it's worth it. The risk that they're being exposed to is not worth the research question you are asking. Now, we also use informed consent. Of course, we do this with humans only. There's no way to get informed consent from animals, but we always get informed consent whenever we are dealing with human participants. If we're dealing with underage participants or maybe participants with a developmental disability who cannot give their own consent, we always ask for the parent or the guardian to give consent. And then, even still, when we're conducting research, we always try to get consent from the child or the individual in some way. So, even if they didn't give written informed consent, we kind of do certain things to make sure that we're not forcing them into participating. So, for example, if you're working with a child, of course, their guardian is going to sign an informed consent to participate in research. But we always ask the child, hey, do you want to come over here with me and work on this thing at the table with me? We're going to do this project. Do you want to come with me? If the child says no, that is not informed consent. Okay, that is not consent at all. So the child has a choice. So even though their guardian or parent said on a piece of paper, yes, our child can participate, if the child themselves the day of says, nope, I don't want to do this, we don't force that. Okay, so we always get consent from our participants whenever we're doing research. To the extent that we can, we inform our participants about the nature of the procedures prior to them participating. So, of course, we can't always tell them everything because sometimes we need a few things to be hidden so they don't throw the data or throw the research. But to the extent that we can, we make sure that they understand what it is they're going to be doing, what they're going to be exposed to in the experiment, and so on. Okay, so we might not give away our hypothesis or our research questions specifically, but if they're going to be sitting in front of a computer for an hour and they're going to be selecting pictures on the screen and they're going to hear a little ding every time they get one right and they're going to hear a buzzer every time they get one wrong, well, we're going to tell them all of those things, right? So we describe it to them as much as we possibly can without affecting our data. We always assure that that their participation is completely voluntary. So whenever we're talking to them about research, we say, if at any point you want to be done, or you want to break, or you want to leave, you can. Okay, so we do not coerce or force anyone to participate or stay in the research. So that means even if they've already started, they can stop whenever they want to. Okay, they have the right to withdraw whenever they choose. Okay, so we never coerce our participants into participating in a project. And then, of course, if deception is involved in any way, we always give them a debriefing at the end of the study, which basically means we would say to them, okay, so we kind of tricked you, or we told you the wrong thing, or we gave you the wrong instructions. Here's why. And you fully explain your hypothesis to them at that point. So once they're done participating in the study, you explain to them what the deception was, why you did it, and you make sure that essentially they're okay. But that is part of the IRB or the review board's job, is to make sure if there is deception involved, it's not harming the participant in any way. So these are our ethical guidelines that we have to adhere to, or we're not allowed to conduct our research. Now, we use the scientific method to approach questions when we're asking questions about human behavior or any other phenomena that we're interested in investigating. So the scientific method allows us to do this investigation systematically and with some level of control to make sure that our findings are accurate and reliable. Okay, so that's why we use the scientific method, and everyone in the scientific community uses the same method so that we're all ensuring that our data is at the same level of reliability. So the first step of the scientific method of course, is identifying your question of interest. So you have to decide specifically what it is you want to investigate. Then we formulate an explanation. This is called the theory or the hypothesis. This is what we think will happen, or what we think the answer to our question is. And then we carry out the research. So we do this to actually prove the theory or the hypothesis wrong. Now, this sounds counterintuitive, but whenever you're conducting research, you never want to develop a hypothesis and then search for data that proves you right. Okay. This is where your own personal bias can come into play and it can actually skew your data. And that would result in a number of things going wrong, including possibly other experimenters never being able to replicate your data. So you never want to try and prove yourself right. You actually want to try and prove your hypothesis wrong. And finally, we communicate the findings. So we relay to the scientific community what it is we did and what we found. Okay, so this is when we write it up, we try to get it published, and so on. And so that's how we communicate our findings to the scientific community, whether or not it's supported the hypothesis. So that's an important note to make. All throughout history, in terms of scientific research, there have been experimenters that perhaps were producing papers and publishing a certain hypothesis. And then one day they did a study that proved that hypothesis wrong. And they still publish their work and they say, we've been looking at this hypothesis wrong. Look at this new data. And they call on other researchers to try and replicate it as well. So even if the hypothesis is not supported, we still want to make sure that we communicate our findings to the scientific community. So, how do we even decide what question we want to ask in the first place? How do we decide what's interesting or what is it important to the study of science when we're asking these questions? One great way to start to find a question is simply by observing others. So, in psychology, we focus on human behavior. So, of course, our questions and our research are going to be about that. Right? So, if we're going to come up with new interesting questions about human behavior, we probably should watch humans behave, right? That's how we're going to develop new and interesting questions. So, anything that makes you ask or wonder why. Why did someone act or react a certain way? Why did they engage in one response or another? These questions and curiosity about these things often lead to new research questions, right? It leads you down the path of finding something new to investigate. And then, of course, you want to turn to the literature. You first have to make sure that no one else has already asked the same question you want to investigate. Maybe there's already a multitude of papers that have looked into this question or this phenomenon, and it's already been answered. There's already enough data on it. You're not going to contribute anything new to the science. So you want to make sure that it hasn't already been done. And then if it hasn't, and you have a question that's sort of a new question, you want to go and see if there's any similar research. So it might not be exactly what you're looking at, but perhaps there's something similar, and you can see what they found and sort of take off from their findings and their future research suggestions to maybe expand on your question. So when we formulate an explanation, this is called a theory. So theories are broad explanations or predictions referring to the phenomena that you're investigating. So let me give you some examples of this, okay? So there's what is called the reinforcement theory. This is a psychological principle that maintains or states that behaviors are shaped by their consequences, and that accordingly, individual behaviors can be changed through rewards and punishment. So, what does all that jumble of word mean? So, what that basically means, or what this theory is stating, is that if a person's behavior is followed by something good or something positive, we refer to this as reinforcement. So if something good happens after their behavior, they're probably more likely to engage in that behavior again in the future. That's the theory, okay? And the flip side of it is if something bad or negative happens after their behavior, which is what we call punishment, then they're probably less likely to engage in that behavior in the future. So this is the theory of reinforcement, or the reinforcement theory, and it can be and has been tested over and over and over again. So you can test a theory, a good theory, you can test it. You can see if it's true or not, okay? The textbook also gives an example of a theory called the diffusion of responsibility. So this theory states that the larger the number of bystanders in an emergency situation, so the more people there are sort of like standing about or passing by, the smaller the shared responsibility each person feels is. So basically, the more people there are around, the less likely it is you as an individual will feel responsible to act. Okay, so that's the theory of diffusion of responsibility. And again, this theory can be investigated. It can be tested, right? You can actually see if this happens or not. Okay, so that's a theory. The second step in the scientific method is for us to come up with ways of testing our theory. So this involves formulating the hypothesis. Now, a hypothesis usually involves proposing a possible relationship between two variables, which are the independent variable and the dependent variable. Okay. The independent variable in research is what the researcher changes. It's what we are manipulating. That's the independent variable. And the dependent variable is what the experimenter is measuring. Okay, so that's what changes after you manipulate the independent variable. So you've got the IV or the independent variable. That's what you as the experimenter actually change or manipulate. And then the dependent variable is the one we're measuring. Okay, so the hypothesis states that if this happens, we expect to see this happen. For example, let's say people talking on their cell phones and car accidents. Those are going to be our two variables, okay? We can investigate this question. Do people get in car accidents more often when they are on their phone than if they aren't, okay? So in this example, our theory may be that talking on the phone results in more car accidents. So the if then is if people are on their phones, we expect to see car accidents more often. I'm sorry, not the theory. That's the hypothesis, right? So the theory would be that cell phones affect car accidents. It's a broader explanation, but the hypothesis is that if people are on their cell phones, there are more car accidents or car accidents increase. Okay, so it's a more specific statement about the theory. So we have the theory and we have the hypothesis. So two separate things. So again, as I stated before, the theory states, predicts or states events in general terms. Okay, so such as the diffusion of responsibility. This theory states that the greater number of bystanders in an emergency situation, the smaller the shared responsibility each person feels. Okay, so then the hypothesis is the prediction of what will happen if we test this theory. So we're going to make a more specific prediction about their behavior. So we would say the more people who witness an emergency situation, the less likely it is that help will be given to a victim. So as you can see, this is much more specific than sort of our broad explanation of the theory as a whole. So again, theory predicts events in general terms, hypothesis makes it more specific. Then we have to formulate our explanation. So you have to turn your hypothesis into a specific procedure that can be measured and can be observed, and hopefully can then be replicated by others in the scientific community later on after your findings have been published. So we have to specify exactly what it is you're measuring and how you're going to measure it. You have to specify where you're going to conduct your observation. And then, of course, you have to state any resources that are necessary for you to successfully carry out that observation. So how are you going to do this? How you're going to measure things, what you're going to use to measure it, all of the things you need to do this. Now, there are many different ways to conduct research and to obtain the information you need to reach conclusions as to why humans behave the way they do. So, again, remember in psychology, we're looking at human behavior. That's what we're researching. Now, all of these different methods provide different levels of evidence. Okay, so first we have what is called descriptive research, which includes things like surveys or focus groups, naturalistic observations, case studies, correlational research. And we're going to go into detail on each of these and what they are in just a moment. But these are all what are called descriptive research. Okay. And generally, these provide weak evidence because the experimenters really have little or no control over what is going on. So recall I talked about at the very beginning that when we talk about control within a research experimentation framework, control is a good thing. You need control to have reliable findings. But this method, the descriptive research methods, often allow you very little control over your data or over what is going on. And then experimental research, on the other hand, provides the strongest level of evidence because in these cases, the researchers or experimenters have a lot of control over the variables of interest, which are your independent variables. It's what you're looking at. And we can best arrange conditions in such a way that we can isolate the relationships between the independent variable, which is what we're manipulating, and the dependent variable, which is what we're measuring. So you have much more control when we're using an experimental research method. But not all experiments are equal either. So some produce results that are better or more accurate than others. And as you continue your education, we're going to talk about throughout this semester different types of experiments and how they're done. But you're going to learn how to discern a good experiment that may provide strong evidence and separate that from bad experiments that provide maybe iffy evidence at best. There are different types of research known as quantitative or qualitative research. And I just want to mention these very briefly. We're not going to get into too much detail, but I just want to specify the difference between these two types. So quantitative involves information that is objectively measured. So this often uses numbers, calculations, or statistics, okay? Calculations are what we call objective. That means that they're not someone's opinion or interpretation about data. When we are talking about an interpretation or an opinion or an intuition about something, that's subjective. It's very subjective. It can be different depending on who it is looking at that data. But when we're talking about quantitative data, this is objective, right? We're using math, we're using numbers, we're using calculations. They can't be interpreted any other way. So they're quantitative data. And then we have what is called qualitative research. So these include things like interviews, focus groups, or spoken words used instead of numbers. So this type of research is often used more when you're doing exploratory research because it is more subjective in nature and there can be more bias that comes into play when you're interpreting the data here. But that is another type of research that is used, is qualitative research. So let's go over some of the descriptive research methods that I mentioned just a couple slides ago. So archival research is the use of already existing data. Now, there is some advantages to this. Of course, it's very easy to collect because the data is already there, right? It already exists. Someone already collected it. But the disadvantage of this include the fact that you're dependent on what data is already available, right? So you may not actually have the data that you need to investigate the question you're asking. You're kind of stuck with what you've got, essentially. And the data may be incomplete because you personally don't really have an idea about the circumstances surrounding data collection and the analyses of that data because you didn't do it, right? You didn't personally take that data, someone else did. So because of that, the data might be incomplete and you wouldn't even know. Okay, so that is one disadvantage of it. Now, this type of research is useful for some things. If you're looking maybe for like general trends, of data over several years or something like that, and you're using archival research to look at that. But really, it provides weak evidence at best. And you're kind of hard pressed to form any definitive conclusions or causal relationship conclusions between events based solely on archival research data. Often, this data, like I said, is used to look at general trends. It's not necessarily used to come to any finite conclusions. So it can be useful for that, but it's not going to be used for something like a causal relationship data. There's also naturalistic observation. So this is where researchers observe a naturally occurring behavior in the normal environment, right? So you just go to the natural environment wherever that organism is, whether it's human or animal, and you don't make any changes or manipulations to the situation. You're just observing and recording. Okay. Now, an advantage of this is that it provides information about how people behave in their natural environments without any interference, right? So you can just see how in the natural environment, how are people behaving, which is useful information. But the disadvantages are that you have no control over the environment, right? So there's a lack of experimental control here. Anything can happen because you're in the natural environment. Any behavior can happen, right, as a result. You can also have reactivity occur. So this is when the individuals behave differently because they know that you're observing them. So even though they're in their natural environment and you would hope that they would behave in the way that they normally would, if they know they're being observed, they might actually be behaving differently. Okay. So even though you're observing them in their natural environment, you may not be accurately observing the normal behavior. Okay, so that is a pretty big disadvantage of naturalistic observation that does happen quite often. And again, even though in this case you've observed and measured events and you have some data for it, you really can't conclude, again, just like archival data, you can't conclude causal relationships between events because your results are correlation at best, right? You don't know if the behavior that is happening as you're observing it is actually the behavior that the individual would engage in normally. So we'll discuss later on the difference between correlation and causation. Now, there is also survey research where people are chosen to represent a larger population and they're asked a series of questions about their behavior, thoughts, or attitudes. Okay. So, an advantage of this is the data can be really useful. You can also use a smaller sample to make inferences about a larger population. So, instead of having to conduct your experiment with a large number of people, you can do it with a smaller number and then make inferences on the larger population with your data. But there are some disadvantages to that, and this includes that the sample might not be representative. So you usually choose your sample at random, and it could be that the individuals chosen only represent a small portion of the population rather than what your desire is, which is the larger majority. And another disadvantage, which is actually a pretty significant one, is that you have no control over whether participants are reporting their behavior and attitudes accurately, right? Survey research, you're really at the mercy of your participants' answers, and they can answer in any way, shape, or form. If they read a question and they think, well, if I answer this question honestly and truthfully, it might make me look bad. So I don't want to answer that question honestly. I'm going to say what I think people would want me to put. So you're at the mercy of them answering accurately. And there have actually even been studies done that look at whether or not people answer accurately. So maybe they ask a question that they already know the answer to and see how often people lie on the question. And we've actually seen data that states that people don't answer honestly on surveys for the most part. So that's a big disadvantage to this type of research. And Survey research is actually quite difficult to get the questions right. A good survey takes a really long time to develop because you have to test the questions with different people. You have to make sure there's agreement with respect to the scale that you're using for measurement of answers. And it often takes a really long time to develop a good survey with significant questions that you can draw any kind of data from. So survey research is used quite often just because it's really convenient, but it's you have to be very careful in terms of how you're interpreting the data. So let's talk about correlational research. So this involves studying the relation between two variables to determine if they're correlated or related to each other. So we measure how correlated they are or the strength of the correlation mathematically. So we can actually measure this numerically. Now, I'm not going to go into great detail about what the correlation coefficient is and what exactly it is we're looking at. If you take a statistics course, you're going to learn all about the correlation coefficient. But I just wanted to mention that this is how we measure correlational research. We look at the strength of the correlation, and that's the correlation coefficient. We can have positive or negative correlations or even no correlation at all. So of course, no correlation would mean that there's no relationship between the two variables that we're investigating, right? There's no correlation between them. A positive correlation means that both variables change in the same direction. So that either they both increase or they both decrease or have an increasing trend or a decreasing trend, right? So if they're both going in the same direction, if both variables go up, this is a positive correlation. But if both variables go down, they're still going down in the same direction, right? So that's still a positive correlation. We can also have a negative correlation. That means as one variable goes up or increases, then we have an opposite effect on the other variable. So as one variable goes up, the other goes down and vice versa. But as I mentioned before, correlation is not causation. It's not that if one variable increases, it causes the other to also increase. So let me give you an example. I have a few examples of this. Let's say that we have two variables, the number of murders that occur and the number of ice cream sales. Okay, so let's say there's a correlation between the two. Let's say that as the sales of ice cream increases, the number of murders also increase. So we would say this has a positive correlation because they're both going in the same direction, right? They're both increasing. But this doesn't mean that selling more ice cream causes more murders to occur, right? It's not causational. It's merely stating that there are two variables, there's ice cream sales and there's murders, and they both happen to be on an increasing trend at the same time, right? Correlational, not causational. They may actually have nothing to do with the other. So again, correlation is not causation. It does not equal causation. So let's look at another example of this. We have two variables again. Here we have the divorce rates in Maine and the consumption of margarine. So as we can see, we have a positive correlation because you see that both variables are decreasing. They're going on a decreasing trend. So it's a positive correlation because they're both going the same direction. But this does not mean that the lower divorce rates cause less consumption of margin or that less consumption of margin causes less divorce. This is only a correlation between two unrelated variables. Now, we can also have what are called case studies. Now, this is an in-depth, intensive investigation of one single person or very small groups, like 2 or 3 people. And the advantage of this type of research is that it provides a deep and thorough understanding of the participant, right? So you kind of know all of the ins and outs of that individual. But the big disadvantage to these types of experiments or these types of studies is that the results are hardly ever generalizable, right? So this means that the findings that come out of this research are almost never able to be applied to other individuals or to the larger population because the study and the findings are too individualized, right? It's a very, very isolated scope. You're only looking at one person. So these findings can't be generalized to the larger population, which is the ultimate goal of research. It is to investigate a phenomenon or theory hypothesis with a smaller group in a sense, maybe not this small, right? Not one person or two people, but with a smaller group, then investigating it with the entire population. But if it's done correctly, you can make inferences about the larger population. But with a case study, you really can't do that. Your findings are not generalizable. So very good research for that individual, and you get a really thorough understanding of that participant's behavior, but you can't generalize your findings for the most part. So now let's talk about experimental research. Okay, so we talked about descriptive research methods, which were kind of all of those other ones, and this is experimental research. So this involves the investigation of the relationship between two or more variables. So in experimental research, we investigate this relationship by changing something about one of the variables and then recording the effects or changes that result in the other variable. Now, in experimental research, as I mentioned before, we have the dependent variable, the independent variable, and also what we call confounding or extraneous variables. So the independent variable, recall, is what the experimenter is manipulating. It's the variable that we are changing as the researcher. And the dependent variable is what is being measured. So it's the variable that is changing after the other variable or the independent variable has been manipulated. Okay. So independent variable, the experimenter manipulates it. Dependent variable is the variable that we're measuring. Okay, that's what changes because of our manipulation. Now, confounding or extraneous variables are those variables that you may not have controlled for that can also change the dependent variable. Okay, so this results in an alternative explanation of your findings, and you don't want these at all. If you have confounding variables or if you have alternative explanations for why there was a change in your dependent variable, this means you did not have strong experimental control. Okay, so let's look at some examples of this. So imagine that a researcher has devised an experiment. We're going to investigate whether giving students more time in class to study can help reduce test anxiety. Okay. So in this example, the amount of study time that the students have in class is the independent variable, right? This is what the experimenter can manipulate. So we would either give them more or less time to study in class. So that's the manipulated variable, that's the independent variable. And the amount of test anxiety the students experience is the dependent variable, right? This is what we're measuring after we make our manipulation. However, extraneous or confounding variables could be things like the temperature of the room, the time of day the student is tested. These could have an influence on the dependent variable as well, right? So it might not just be the amount of study time. Maybe it's how hot or how cold the room is, or if you test them in the morning versus at nighttime. So really, to control for all of these extraneous variables, the researcher has to ensure that all students are tested at the same time of day and in rooms that are the exact same temperature every single time, right? So you want to avoid and control for these confounding variables as much as you possibly can. Because if you don't, people could argue that your findings are due to one of these variables, right? They could say, well, The students had more test anxiety because some of them were in a very cold room instead of the others who were in a nice toasty room, if toasty warm room, let's say during the winter time, right? So that gave them more anxiety and not the amount of study time they have. And that's not what you want. You want to be able to state that your findings were due to your independent variable. Okay, so you need to control for these confounding variables as much as you possibly can. Let's look at another example. You could be investigating how manipulating the accuracy of feedback affects the number of work tasks that might be completed. So again, in this example, we have the independent variable, which is the accuracy of feedback. So this is what the researcher or the experimenter is manipulating. This means we change how accurate feedback is. So maybe sometimes it's 100% accurate, maybe sometimes it's 50% accurate, maybe our feedback is never accurate at all. And we see how this manipulation of the independent variable affects the dependent variable, right? Which is the number of work tasks completed. So what we're looking at is if we change how accurate our feedback is, does this then result in a change in the number of tasks that are completed? Right? So does the change in the dependent variable that we're measuring, is that a result of our manipulation? Okay, so that's what we're looking at. One more example would be a researcher investigates whether having preferred activities available increases the activity levels of elderly individuals with dementia. Okay, so if we provide them with more preferred activities, so that's our independent variable, right? That's what you're going to manipulate. So maybe you offer sometimes a high preferred activity, maybe a medium preferred activity, maybe a low preferred activity, one they don't actually like. And every time we manipulate that, we see if activity levels change, right? That's the dependent variable is activity levels. So do those increase or decrease depending on how preferred the activity is that we're providing, right? So that's what we're manipulating. So again, independent variable, what you as the experimenter are manipulating here, it's the preferred activities. And we're measuring the activity levels. And what you're measuring is the dependent variable. Now, experiments typically involve two groups, okay? And we have the control group and the experimental group. These groups are really important when we're looking at experimental research. So a control group is the group participating in the experiment that does not receive the treatment, okay? You don't change anything. So the group basically completes the experiment or behaves as they normally would without any of your manipulations put in place. So you don't change anything. And then you have your experimental group. And for these participants, these individuals, they do experience your treatment, right? Which means your manipulation, whatever it is you're manipulating. This group, the experimental group, experiences that. So let's look at an example of this. A clinical psychologist conducts a study that involves 10 people. Okay, so he has 10 participants. He thinks that he can cure depression by giving clients a particular type of pharmaceutical drug. Okay, so he's going to give all 10 of these people the same drug. So he prescribes the drug. He finds that 60 days later, all clients show fewer signs of depression. He has concluded that he cured depression. Okay. What is the problem with this? Well, there's no control group, right? How do we know that, all of these people didn't, I don't know, get a puppy and now they're happier? Or maybe all of them in the time they were taking the drug, maybe they met someone. Let's say they were all dating and they all happened to meet someone in this 60 days that they were taking the drug and they are less depressed. You don't know because there's no control group, right? You gave the prescription to all 10 of the people. You don't know if it's actually the drug or if it's something else. Now, if he had only given the drug to 5 people and the other 5 were not given the drug, but only the people who were taking the drug, their depression went away, you could definitively say it was the drug because let's think about this. Let's say, let's look at one of my examples where I said everyone got a puppy and everyone started feeling better. Okay, so only 5 people get the drug, the other 5 do not. You could still say all 10 of them got a puppy, right? But we can definitively say that it's not the puppy that's causing those 5 individuals to feel better or be less depressed, because the other 5 people who didn't get the drug are still depressed, even though they have the puppy. Okay, so it's clearly the drug, not the puppy, that affected those 5 individuals that are being given the drug and their depression levels decreased. You couldn't say that when you give all 10 people the drug. But if you have a control group and you have an experimental group, you can definitively say, well, it was the drug, right? That's what decreased the depression. So without the control group, you can't rule out any other explanations. You must have the control group in place. When we use control groups and experimental groups, individuals are randomly assigned to each group. Now, sometimes it's even a double-blind assignment, which I'll talk more about in a little bit, but this basically means that the experimenter doesn't even know which group is which, right? They don't even know if you're doing, say, a drug study, they don't know which is the control group and they're getting the placebo drug and which is the group that's getting the actual drug. So sometimes you even have assignments such that the experimenter doesn't even know who's in which group. And this is all done, random assignment and double blind assignment. These are all done to avoid any biases that can influence the findings, right? So you have much higher or greater experimental control when you do this. So in random assignments to each condition, so participants are assigned to different experimental conditions or groups on the basis of chances alone. So that's what we mean when we say random assignment. They're just randomly or by chance alone. Often you use maybe like a computer generated randomization that you would use to place people in different groups or something like that. So you're not hand picking them for each group, you're randomly assigning them. The groups should be comparable as much as you possibly can. So things like, certain ethnicities or sex or gender or income, you kind of want the groups to be equitable as much as you can. But this is really difficult to do, right? Because you have so many things that you have to take into account that you can't always get equitable groups. And then that can also skew your data because maybe one group has, more of something in it than the other, right? And it can actually skew your data. So the goal is to have your groups be comparable, but that is really hard to do and doesn't always happen. So here's just a picture, just kind of an example of what this looks like when we're doing randomization or random assignment. So first we identify all of the participants, right? So you make sure that anyone that's participating meets the requirements of the research. You always have some sort of requirement. In the research that I had done in my master's, I worked on several projects, but one of the projects I worked on, we used Tagalog words in the experiment. And it was important that nobody spoke the language Tagalog. So one of the requirements for people to participate was you could not know the Tagalog language. Okay, so that's what I'm talking about when I say there are certain requirements all participants have to meet before they can be part of the study. So first you identify participants and then you randomly assign them to the condition. Okay, so you use some sort of computer randomization to do this. Then you manipulate the independent variable. So for the control group, remember, there is no independent variable, right? We don't manipulate or change anything, but for the experimental group, we do. But then you measure the dependent variable in both groups, right? Because what should happen is you should see a change in the experimental group, but you should not see a change in the control group, right? Because you didn't manipulate anything there. And then you compare the results of the two groups. Here are just some important terms that I want to make sure you're aware of and you remember. So we can have what is called a confederate. So this is someone who's employed by the researcher who participates in the study and they pretend to be a participant. You may do this for a number of reasons. Sometimes you need to observe the behavior up close to the participant, but you don't want them to know they're being observed. Remember, I talked about earlier when we observe people in their natural environment, we can have what is called reactivity, where they behave differently because they know they're being watched. So what we can do is we can employ a confederate who pretends they're also a participant, but in actuality, they're observing the other participants who are in the study. Replication is a term that you definitely need to be aware of, because we always want to ask ourselves, can we replicate experimental procedures and results? This is extremely important. If the scientific community cannot replicate your findings, they're going to be called into question, right? Your findings may not be accurate and reliable, and they're going to question them. So scientific understanding of different phenomena and hypotheses and so on, these are based on a cumulative knowledge, right? Based on research that has been done by multiple researchers in different labs over multiple years and so on. It's not a one-time only experiment. So replication is a vital piece of our science and of research. It has to be able to be replicated, your study and your findings and data. When we talk about significant outcomes, so when we say there's a significant finding or a significant outcome, we're talking about a statistical term that involves some sort of statistical analysis. So we're stating that there's some sort of statistically significant difference between groups. So when you compare the differences between the groups, so recall on this previous slide, where I said we compare the results of the two groups, right, after we measure the dependent variable. We use statistical analyses to determine if these differences are significant or not. So sometimes there are differences, but they're very, very small differences. So we wouldn't say that they're significant, right? They're not large enough to matter. So whenever we're looking at outcomes or our data, we want to see if there's actually a significant difference. And we use statistical analyses to look at that. Another term is experimental bias, and these are factors that influence the independent variable, and it affects the DV. So experimenters and researchers often have expectations. Participants have expectations, and these biases that we bring to the table as human beings can affect the data. So it's something that you need to be aware of. Often to control for experimental bias, we always have a second implementer who is also there collecting data. So that way, if one person is more biased towards a certain result and maybe they're collecting data a certain way, having that second experimenter there also observing will kind of control for that. Because then what we do is we look at and compare the data of the two experimenters, and we actually get a percentage for how accurate they are between the two of them. We also have what is called a placebo, and this is the false treatment, right? So this is usually, when we say placebo, we're talking about drug or pill experimentation or research, which basically just states that this is the control group. They're still taking a pill of some kind, but whatever's in that pill has no chemical properties or active ingredient. So it's a placebo, right? It's just sort of a nothing pill. But they still, of course, have to take a pill or they would know they were in the control group, right? So that's what we're talking about when we talk about placebo. And then finally, double blind. So this is when both the experimenter or researcher and the participant are blind to who's receiving a particular treatment. Now, often in research, the participants are always blind, right? Like they don't know if they're in the control group or the experiment or in the experimental group. But in a double-blind study, the experimenters also don't know who's in the control group. So the way this is done is they'll take group 1 and group 2, and this is often done with drug studies, honestly, and they're given 2 drugs from the pharmaceutical company. Let's say one is blue and one is pink. But the company doesn't tell the experimenter which one is the actual drug and which one is the placebo. Okay, so they're just given drug A and drug B, and the experimenter doesn't know. So they just assign one group to drug A and one group to drug B, but they're not sure which is the control group or the experimental group until the end. And this is done to eliminate any bias or subjectivity that might occur from the experimenter knowing which drug is being administered. And that is all for Research Methods, Chapter 1.